Okay, for our last set of notes for this unit, we're going to look at correlation versus causation. We've done correlation before when we've done scatter plots, and a correlation is just the measure or degree of a relationship between two variables. And again, two variable statistics is what we're working on. So we've done the three types of correlations before, but just as a review for correlation, if one set of values, if we're looking at either a scatter plot or we're looking at a table of values, if one set of values increases and the other set also increases, this is going to give us a positive correlation. Because basically when we graph it, it's going to look like a positive slope. It's going to go uphill. If we have one set of values increasing but the other one decreases, that's going to give us a negative correlation. And that's going to be like a downhill slope. And then if the change in values of one set is not affected by the other, it means that they're all over the place. There's no relationship between the sets of data. There's just points all over the graph. This is said to have no correlation. So it's just a bunch of scattered plots or scattered dots all over the place. So again, correlation, positive, negative, or no correlation. And that's if there's a relationship, or it's the measure of the degree between the relationship of the two variables. A causal relationship is a little bit different, and that's what we're going to look at tomorrow in class. A causal relationship between two events exists if the first event causes the other. So the first event, just like in language arts or any other class, is called the cause. And what that event does to the second event is called the effect. So a correlation between two variables does not imply that one variable caused the other. On the other hand, if there's a causal relationship, then they have to be related. They have to be correlated. And we'll talk more about that in class tomorrow. So in example 1, a study shows that there's a negative correlation between a student's anxiety before a test and the student's test scores. In other words, the higher the student's anxiety, the lower the test score. So there is a correlation. As one thing is increasing the anxiety, the test score is lowering. But does the causation, does anxiety cause a student to earn a low test score? And the answer is, in this case, probably yes, but can we prove it? We don't really know. Example number 2. A study shows that there is a positive correlation between the numbers of hours a student spends studying and the student's scores on a test. So in other words, the more hours spent studying, the higher the test score. So does more studying result in a higher test score? If the answer to that is yes, then it has correlation and causation. If the answer to that is no, then it has correlation but no causation. Does studying more cause you to get a higher test score? And in my opinion, the answer to that is yes. So we're going to use the graphing calculator to enter the data in the table below. So this data is the weight of a growing puppy in New York and the retail price of snowshoes in Alaska. So when you first look at it, is there any relationship between those two? And we're probably going to say no. And if there is there a correlation between the two? So put that data in your list 1 would be the weight of a growing puppy in New York, and in list 2 is the retail price of snowshoes in Alaska. And then when you're done, you need to find the equation for the line of best fit. So once you've done that, the equation for the line of best fit should be y equals 9.927x plus 25.089. And the correlation coefficient, we're going to use r squared, is 0.996. So by looking at the correlation coefficient, that tells us that there is a strong positive correlation between the weight of a growing puppy in New York and the retail price of snowshoes in Alaska. Does it make sense? No, but according to this data, and according to our correlation coefficient, there's a strong positive correlation. So does this imply causation? So what that means is, does the weight of a puppy cause the price of snowshoes in Alaska to go up? And the answer to that is no. So there is a correlation, but there's no causation. And why is there no causation? Because we cannot prove that the weight of a growing puppy in New York will cause the retail price of snowshoes in Alaska to increase. But there is a correlation. Doesn't make sense, but there definitely is a correlation. Now it's your turn to answer the multiple choice question and the free response. Identify whether this is an example of causation or correlation. The age and the number of toy cars owned. Number 2, is it possible for two things to have a causal relationship but not be correlated? So go back and look at your definition of correlation for that one and your definition of causation. And we're going to talk about this more in depth in class tomorrow. We're going to look at an article that explains causation and correlation. But correlation just means two things are related either in a positive way or a negative way. Causation just means that does one thing have an effect on the other. Make sure you answer those questions in the Google form as well. And this is our last set of video notes for this unit for this school year, so give yourself a pat on the back. And keep calm and love math.